Hello, everyone, and welcome to the webinar. My name is Tyler Grubbs, and I support Oak Ridge National Laboratory in their crowdsourcing initiative. Before we get started, I'd just like to briefly discuss some logistical points. The webinar is being recorded, and we will post this online on the JUMP website after this concludes. All participant lines have been muted, but if you have any questions, we encourage you to ask. Just use the Q&A box or the chat box or raise your hand, all in the webinar panel. We'll pause to take these clarifying questions throughout, and then at the end we'll also go through and address those on more of a one-on-one basis. I'll now turn it over to Melissa Lapsa. Melissa is the group leader of whole building and community integration at Oak Ridge, and she's also the leader of the lab's crowdsourcing efforts right now. Melissa?
Great, thank you, Tyler. Welcome everyone to our webinar on JUMP. And if you're wondering what JUMP is, it's join in the discussion, unveil innovation, motivate transformation, and promote technology to market. And it's our new crowdsourcing campaign. And I will go through an overview of what that means and how you can participate with a few slides. But first I wanted to introduce Dr. Steve Memory. And he, since 2009, he has been a director at the Corporate Technology Center for A.O. Smith Corporation, a major manufacturer of residential and commercial water heating, water treating, and boilers. And also Dr. Kyle Glusenkamp, who joined ORNL, Oak Ridge National Lab, in 2012. He's an expert in thermodynamic cycle analysis and experimental evaluation, with research focusing on energy-efficient water heating, appliances, and sorption systems. So I'll go through a few slides outlining what JUMP is in our crowdsourcing activity and how you can participate. And then Dr. Memory will go through the technical details of A.O. Smith's campaign, his technical challenge. And then Dr. Kyle Glusenkamp will also add some information at the end of our presentation, and then we'll open it up for questions. So with that, we'll get started. So crowdsourcing is essentially an open website platform for innovation and for a space where people can add their ideas and share comments and dialogue about different topics. And what we're doing is crowdsourcing for energy efficient technology ideas and solutions. And the White House recently put out a blog that said, while only a fraction of Americans are formally trained as professional scientists and engineers, everyone can contribute to science through innovative approaches such as crowdsourcing projects. And the Assistant Secretary at the Department of Energy for Energy Efficiency and Renewable Energy recently said, while he was commenting about why he liked crowdsourcing, that the smartest people don't all work for you. So crowdsourcing is a great way to open up a website for thousands of people to be able to go online and provide their input to ideas. And Oak Ridge National Lab is not the first organization to do crowdsourcing. There's a lot of great organizations out there doing that and getting great results, such as General Electric and Local Motors. So we started this crowdsourcing activity last year, and we were really focused on building technologies, and we started with 3 general topics. We looked at envelope technologies, equipment technologies, and sensors and controls. And really we just opened it up generally to say, what's the public's ideas for new innovation for technologies that save energy in those 3 areas. And we were excited that we had over 5,000 unique visitors to the site, using the site, and we were able to post over 70 great ideas. We then had a panel of judges that evaluated those ideas based on their technical feasibility, potential for energy savings, and their innovation. And each of the winners, so we had a winner for each area, were invited to attend our Industry Day event that we hosted at Oak Ridge National Lab in September to present their ideas and network with over 300 people who participated in the event. And one of the ideas was 3D printed to have on display at the event. And another crowdsourced winner submitted his idea to the Department of Energy Small Business Voucher Program, which is an opportunity for up to $300,000 of technical support provided from one of the DOE national labs. The first round of that program just closed, but there's another round opening up in February. Another winner is talking with Oak Ridge National Lab about a potential cooperative research and development agreement. So there's lots of great outcomes that can occur from sharing ideas and crowdsourcing for innovation. So what we wanted to do this year was to try to increase the impact even more. And so we've teamed with 3 great industry partners, A.O. Smith, GE, and United Technologies Research Center, to really look at what are the technical challenges that we can help them with through crowdsourcing. And we intend to post more campaigns this year. We're just starting with these 3, but we're excited to have 3 exciting campaigns running. And they're all 3 posted on our website at web.ornl.gov/jump. And A.O. Smith, who's on the line, is providing a $5,000 cash award for the winner of their campaign. There's also opportunity for in-kind technical support from ORNL of between $10,000 and $15,000. I mentioned we'll also link small businesses to the Small Business Voucher Program, which can provide up to $300,000 if it's approved. And there's also opportunities for future collaborations with ORNL and our industry partners. So we're really excited about partnering with industry to help move the innovative ideas out into the marketplace and have that energy efficiency impact hit the market for quick impact. So going into the details a little bit of how it works, how this website works, if you go online and register and become a user, you post your idea for one of those campaigns, and then ORNL will take a review of those ideas for technical, economic, market readiness, customer interest or need. The ones that are deemed valid will be posted to the website, where then they're open to the public to vote on and comment on for about 8 to 10 weeks. And following that, we will have that technical panel of judges working with A.O. Smith to determine what are the best ideas, and the very best idea will be, of course, awarded as the winner, and they may also be able to go to the SBV, apply to the SBV program for funding. We'll be doing networking opportunities, we'll do recognition opportunities, and all of that will be in a 6 to 8 week time frame after the judging. So how does intellectual property work? This is a question that we get quite often. The innovator who's submitting their idea owns their idea, so they own their intellectual property. If they want to protect that intellectual property, they should do that before they post it, because once it's up on the website, of course, it's publicly accessible. So they will want to, if they want to protect that, they should do it before they post it. Now, if the idea is a winning idea and there's more collaboration that results from that as for the winner, there may be additional IP developed jointly. For example, if ORNL were to add to the idea through the technical support or the small business voucher process, or perhaps when the industry partner may co-create or co-develop that idea even further with the winner. So in summary, I encourage all of you to get involved with the JUMP program. It's a great idea to be able to post your ideas for these different technical campaigns. And we're going to hear next about the A.O. Smith campaign. We had a webinar yesterday on the GE campaign, which we'll be posting online shortly. And we had one earlier today with UTRC, and which we'll be posting online as well. Again, each of these industry partners is given cash prizes, and there's also opportunity for in-kind technical support and potential future collaboration. So with that, I will turn it over to Dr. Memory to go through his technical campaign.
Okay, thank you, Melissa, and good afternoon, everyone. I think it's important, first of all, for everyone to try and understand why we're interested in this. In other words, what's the value proposition? There needs to be a value proposition, obviously, for the customer as well as the manufacturer. So what's driving this idea is that in April of this year, there were changes in the minimum efficiency, energy efficiency standards for residential water heaters. And anything above 55 gallons in storage volume required the use of alternative technologies for both electric and gas, really mandating, condensing water heaters for gas products and heat pump products for electric products. And since 55-gallon volumes can no longer be manufactured, customers will not be able to attain what we call the first hour rating afforded by the larger tanks using current storage technology. Now, the first hour rating is something that people might not be familiar with, but it's something that we all certainly understand when we run out of hot water. Definition is there. It's the term used to define the amount of hot water the heater will produce in the first hour of use after a full recovery. It depends on both the input of the water heater and the volume of the water heater. And clearly it's important when you want to take back-to-back showers or multiple showers, or you want to fill up a tub. No one likes to run out of hot water. So it's quite an important number that we have. And so it is posted typically on the energy guide label to help guide the customer in selecting the best heater for their given application. So being able to increase the thermal energy density allows customers to maintain or increase the first hour rating in smaller volumes without the penalty of a more complex or expensive technology, and that's what's driving this. There are other things that drive this type of idea, in that thermal storage is definitely an alternative way of storing intermittent energy from renewables. There are a number of utilities today that are looking at using thousands of water heaters as a way to balance the grid and all these intermittent energy sources from solar and wind as well. So being able to increase the energy storage from residential water heaters is becoming a very interesting topic. Next, please. So this is a fairly complex looking chart, but I thought it was worth spending a couple of minutes going through the standard test for first hour rating, a DOE mandated test, and it looks complicated, and if you don't know how to do this well, I mean, obviously this enables all water heater manufacturers to put a standard number out there, because we'd all like to put as large a number as we possibly could for a given volume, but this standard test ensures that we all do it the same way. And I just wanted to explain this such that people realize that it probably should be conducted at a certified lab. And there are essentially 4 colored lines on this chart. The dark red line is the outlet water temperature from the water heater. The lighter red line, or pink line, is actually the temperature as measured on the left-hand axis there that controls the thermostat. The blue line is the accumulated first hour rating, in other words, the amount of gallons of hot water that this water heater will produce. And then the orange line at the bottom there just indicates when the burner is on. So just a few key points here. The test starts at a given outlet water temperature, say 135 in this particular case. That's point number 1 there. It stipulates that you draw 3 gallons per minute initiated there, and that draw continues. Clearly, about 2 minutes into the test here, you can see the thermostat. This is the temperature in the light pink now. It drops very quickly. So the thermostat, the set point is reached. So it says, please turn the burner on, or please turn the element on, whichever type of water heater you're looking at here. So it turns the burner or the element on here after 2 minutes. That's set point 2. The draw continues until point 3, when the outlet temperature has dropped to 25 degrees below the temperature you started with. So in this case, if you started at 135, when the outlet temperature from that water heater reaches 110 Fahrenheit, the draw stops. And you can see that by the blue line here. You can see the accumulated draw then just levels off because it stopped. The burner is still on, so you can now see over the next 30 or 40 minutes the burner is still on until the thermostat, the set point temperature in the light red line, or the air, reaches 0.4. It reaches the set point temperature, at which point the burner switches off and you restart the draw. So at 0.4 you restart the draw, and it just repeats really what I said on the left-hand side of the chart. Now it repeats it on the right-hand side. You continue, you draw 3 gallons per minute. 0.5 the burner comes on again because the thermostat's requiring that, and then you continue up until 0.6 where the burner cuts out at 60 minutes. It's a 60-minute test, but you're allowed to continue the draw to accumulate first hour rating until you reach that 25 degree below the set point again. So it continues until you reach, in this case, 110 degrees again. And then you simply add up the accumulated draw from both of those draws there. There might be some water heaters that have more than 2 of these draws. There might be some that only have 1. This is just a generic plot showing you how we actually measure first hour rating. So in this particular generic water heater, we get a 68-gallon first hour rating. And that's how the test is done. Next, please. So what I did to try and sort of frame the particular campaign we're looking at is I went to the AHRI, the American Heating and Refrigeration Institute, their certification data. We all have to provide our certification data to this group, and they can publish all these. And so all the manufacturers of residential electric and gas water heaters publish their information. And what I simply did is I just took some numbers from that certification data. So these aren't anybody's particular water heaters. They're sort of an average. And what I'm plotting here is first hour rating on the left-hand side, tank volume on the x-axis here. And you can see the actual points are showing what the first hour rating is at the particular, it's an average first hour rating. Some water heaters will be a little bit more, a little bit less, depending on the input, of course. But it's a sort of average that certainly shows you how the first hour rating varies with tank volume. Next. So as of April of this year, new standards came in, and we could not now manufacture conventional storage tanks of greater than 55 gallons. So if we wanted to get the storage, can you hit next? If we wanted to get the first hour rating from a 65-gallon tank, okay, next. We would require, if we before April of this year, out of a 65-gallon tank, we could typically get 115 gallons for a gas water heater and 73 gallons first hour for an electric water heater. What we're trying to say is, can we get those same first hour ratings out of a 50-gallon? Can you hit next? And if we can do that, that represents a 20 to 25% increase in first hour rating in that smaller volume. So that's the challenge. There are a number of ways we can do this. Can you hit next? Obviously, there are innovative methods, phase change materials, but what we essentially want the campaign to be is to deliver as much hot water as a 65-gallon tank produces pre-April 2015 in a 50-gallon tank today, say representing a 20 to 25% increase in first hour rating. So what, let me just, next please, if we can just stress the challenge again. So I've tried to sort of summarize there what we want. We've got a conventional storage discontinued at 65 that gave us for a natural gas 115 and for electric 73 gallons of first hour. If we want to, you can see where we are on a conventional storage at 50 gallons today. So you can see a successful solution to the jump challenge will be if we can hit that rated volume of 50 gallons and get the 115 or greater than 115 or greater than 73 gallons. Again, some of the constraints that we've put on this you can see down below. Clearly you could just increase the storage temperature and use a mixing valve. We don't really want to do that. There is always a concern of scalding, so we don't really want to increase the storage temperature. We'd like to obviously stay within the existing dimensional footprint. becomes very important for where some of these water heaters are installed. We don't want to negatively impact what we call the energy factor, which is today's efficiency rating. Now, this is going to be superseded by something called the uniform energy factor, but the same sort of thing. You can go and look up energy factors or efficiencies of these water heaters, again in the HRI data, and I can give more information on that if people want. And by the way, you can go to the Electronic Code of Federal Regulations and look up that 10 CFR Part 430 Subpart B Appendix E and look at these tests, but also look at how they measure energy factor, which is again a fairly convoluted test. Must not negatively impact the service life of the water heater. Must not negatively impact the safety aspects of the water heater in terms of flammable vapor and things like that. And of course, there has to be, we can't increase the manufacturing cost by more than around $150 at high volume. So those are some of the constraints, and if there are any questions on those, I'll be happy to take them at the end. Okay. Next. I think now it's Kyle.
Right. So thanks a lot. Dr. Memory talked about the value proposition, so I want to highlight also the impact that we're talking about here. Water heating is big. I mean, it's 4% of all U.S. primary energy consumption. That's all energy consumption, including transportation, industry, everything. So water heating is actually pretty big, and small improvements in water heating can make a big impact. Industry is moving towards more efficient systems like heat pumps, but ultimately more options is always better. The more tools we have in the portfolio of energy efficient technologies, the better we'll be. So specifically, a cost-effective improved energy density means you can get more hot water out of the same footprint. This could potentially be applied across all storage type water heater categories. That includes gas and electric. It also includes heat pump and solar. In the heat pump or solar product category, having more energy stored in the same footprint means that there's less reliance on backup heat, and that means that you're going to have a better overall appliance efficiency. And in addition, having more energy stored increases opportunities for demand response, as Dr. Memory mentioned, where utilities are trying to use water heating as effectively electric storage for the grid. Next, please. So the challenge is open to all thermal storage types. It does specifically say that we're looking for a thermal storage solution, but as you see in the categorization below, which comes from a paper from 1983, materials that store thermal energy can be divided into sensible heat, latent heat, and chemical energy categories. So these are all of interest. It's also open to not only materials but methods, keeping in mind that those methods must not violate the constraints that Dr. Memory outlined, especially with regard to the way the FHR test is conducted and the way the EF test is conducted. So I just want to highlight one example here, the solid-liquid phase transition, phase change materials. Next slide, please. Here's an overview of some of the materials that are out there that can store energy in a liquid-solid phase change. So these are commonly referred to as PCMs, phase change materials. You see at the x-axis we have melting temperature. So in this particular challenge, we'd be looking at things in a melting temperature in the order of the heat of water, hot water, on the order of 40, 50 C. And so you can see there's quite a few options out there. This is a high-level overview. If you drill down into any one of these categories, there's a lot of options. And these are all possibilities, but not the only possibilities for meeting the challenge. Next, please. So Oak Ridge National Lab has extensive expertise in the development of novel systems, including energy-efficient water heating technologies. We're also capable of performing third-party validation of performance. That includes EF testing that Dr. Memory outlined. Just to give you another piece of information about EF testing, this is a list of draws that would be imposed on a water heater over a 24-hour period. in order to conduct the energy factor test. Of course, this is just the draws. There's also a lot of requirements with regard to the temperature and humidity that surround the water heater at the time of the test, and with regard to the uncertainty of the instrumentation used to evaluate the test, and so on. Next slide, please. So the Oak Ridge National Lab has a long history of successful relationships with industry partners. Basically, our mission is to help bring new products, new energy efficient products to the market. So that's what we're positioned to do. That's what we like doing best. Next slide, please. And with a successful entry to the contest here, there's the in-kind support as well as potentially the small business voucher funding, which one way that could be utilized is to draw on Oak Ridge National Lab's expertise for not only validating the prototype, but potentially also developing the prototype further. And as you can see here, I'm showing, for example, in the picture in the middle top is some testing that we did on a whole bank of water heaters. That was accelerated life testing. On the upper right is a prototype system which was developed here. And on the bottom you see one of our environmental chambers that can be used for evaluating these systems. We have a number of awards, as you can see on the left there. And I think that's the last slide, so appreciate everyone's attention.
Okay. So as our final slide here, basically wanted to remind everyone that the deadline to submit ideas on the JUMP website is January 15th. And if you have follow-up comments or questions after today's webinar, you can email myself or Dr. Memory or Dr. Glusenkamp for additional information. And with that, I'll turn it over to Tyler to see if any questions have come in.
Yeah, we have several. I will read these aloud, and whomever would wish or feels less qualified to answer, please do so. First one, a gentleman asks if, I guess for you, Dr. Memory, are you aware of the establishment of a new product category for grid-enabled ETS water heaters with volume of 75 gallons and larger, as well as an activation lock that ensures that the unit only becomes operational when enrolled in a utility demand response or load management program?
Yes, I am aware of that, and that was a specific thing to said for the grid enabled. We are aware of that, obviously. Yeah, I don't know what the question was, but yes, we're aware of that.
I think it was just gauging your awareness. I'm not sure the ultimate end, but whoever asked that, again, you're more than welcome to chime in with clarification. We have another question. A gentleman asks, if we're using phase change materials, should we target a set point of 135 degrees Fahrenheit for best results in the FHR test?
I think that, yeah, I mean, if you can verify it at that temperature, that would be fine, yes.
Okay, great, thank you. Another, oh, I'm sorry, go ahead.
Steve, I'll leave that question ultimately to you, but from the manufacturer's perspective, but there is the recent change in temperature, right?
Yes, there is. I mean, as you said, Carl, there are many different combinations that we can use here. I think if we can verify the methodology here, then that would be a huge step forward. See what I'm saying?
Yeah.
I guess I'm not too worried at this point about the exact temperature. I understand that it might change between a wax and a salt or whatever. And we have looked at both types of phase change materials. But again, the absolute temperature here, I'm more interested in the methodology of being able to increase storage and not so much in actually defining the phase change material itself, I guess. because there are all sorts of changes coming on temperature. Set point.
Hey guys, would you mind if I brought the gentleman that's a question online, so maybe I'd like some clarification?
Would that be helpful, Kyle and Steve, if we unmute the line so that we can have a discussion on it?
Sure.
Okay. Hello, Josh, are you available? Okay, Josh, I must have been satisfied with your previous responses, so thank you. We have another question. To clarify, a 50-gallon gas condensing water heater cannot achieve the FHR of a 65-gallon gas non-condensing water heater?
Kyle, do you want to take this one? I mean,
The question
yes,
is,
there aren't many condensing residential water heaters on the market, and there is a significant penalty in cost. Kyle, do you want to add to that?
yeah, I believe if they're at the same capacity, then their first hour ratings should be pretty similar. I guess I'm not sure exactly how to answer the question. I think it's getting at what's the difference in the FHR of a condensing versus a non-condensing. I think the difference in FHR has more to do with the capacity of the burner in each case and the configuration of the inlets, outlets, and the heat exchange surfaces than it does to do with the type of technology, whether condensing or non, that's used.
Yeah, I mean, I guess I wanted where I wanted to go with this was if you need to go to condensing technology, there's a significant increase in cost to the customer. So I guess the value proposition for me is to try and get the first hour rating without the need of going to a condensing technology.
Okay, thank you. We have another gentleman asking, or stating he's working on detailed calculations for a solution, but he is concerned that someone might post a similar, though underdeveloped idea before he does so. Would you recommend posting something now and following up with more detail, or perfecting the design and posting a more complete solution later? I suppose in its entirety.
Do you want to? Seems to be more on the IP side.
Yeah, I think that I would probably say to go ahead and post something now, and that way that it's up there and you're the first to post that solution, and it's time and date stamped, and then you can follow up with more detail as you'd like to, because it's been open for additional information.
So Melissa, there is a mechanism to continue to edit your idea once it's posted. Is that what you're saying?
Yes.
Yes, you can edit an idea after it is submitted. So if you should want to revise, add, or even case prove, subtract, all submitters are more than welcome to do so. Is the phase change material technology for water heaters restricted to only solid phase change materials?
No.
Okay, excellent. And Melissa, if you want to touch on this any further, I'm not sure, but we have another question. How do we protect intellectual property for any submission?
So you'd want to protect that before you post it, but that idea is, of course, the submitter's idea, and so you own that. But of course, once you post it on the website, it's open for everyone to see. So if you're worried about sharing it, you should not share it. If you want to protect it, you would want to do that before you would post it.
Great, thank you. That appears to have exhausted the questions we have for the moment, but I certainly do encourage anyone on the line, if you do have remaining outstanding questions, please send them. I would be happy to answer them. In the interim, or in the absence of any further questions, I would just like to thank everybody for joining us. We really appreciate all of your interest and your support so far. As Melissa touched on, we had great success with the first round, and we anticipate only more such success and more growth as we progress. Now with corporate partners, such as the ones we have graciously joined us on the line today with our campaign. So again, we will be posting this recording on the JUMP website shortly. Also be sending out the slides themselves, and then therein on the website and the deck, a number of email addresses as well as text launch if you have questions, concerns, or any clarifying issues you'd like to resolve. We also have a fax posted on the JUMP website, so a number of resources at your disposal should you wish to clarify or learn more. That aside, I'd just like to thank all of our panelists and wish everyone a wonderful day and a successful campaign. Thank you.